Hello dear students, welcome back to C60 series of our IPE exam. Okay, so this is our first year chemistry booklet for your IPE examination. Okay, so this booklet contains all important questions, blueprint and everything. So now using this booklet from our NEET World, I will be explaining you the 8 marks question first. Okay, so in the last sessions we have covered structure of atom for your 8 marks LAQ. Okay, that is Bohr model as well as quantum numbers we discussed, and after that I also covered the periodic properties, that is from classification of elements. Okay, so now in this session we will be covering the other questions from this classification of element, and the next chemical bonding will be also covered for your LAQ 8 marks questions for your first year IPE examination. Okay, so if you haven't watched those sessions which are highly helpful, definitely there will be one question from those previous discussion in your final exam. Okay, so now again, so with this discussion you are going to get 2 8 marks questions for your final exam. Okay, right. So look at this, and I hope you know that the questions, LAQ questions, are from 3 chapters. Those are structure of atom. First one is from structure of atom, and the second question is from periodic table, and third question might be from organic chemistry. Okay, so these are the 3 chapters we need to focus first for your 8 marks, and along with this, sometimes if not in organic they may ask from chemical bonding. Okay, so this 4th chapter, this is also you need to look into it. Okay, because this chemical bonding, if they are not asking in this 8 marks question, they can make a 4 marks question from this chemical bonding if they are not making a 8 marks from it. Okay, so definitely these 4 chapters to be focused first from your first chapter, I mean first year chemistry part. Okay, so after finishing this you can have your total 16 marks from 2 LAQ questions out of 3. Okay, so there will be 3 LAQs in which you need to attempt any 2. Okay, so those 2 questions, most of the cases it will be only from these 4 chapters as per your blueprint of first year IPE. Okay, right. So now here in this session you can see what is periodic property, how do the following properties varies across a period and down the group they will ask. So this discussion was already completed in the last class, so I am not going to discuss it again, but if you are not knowing about this, how to attempt or what to write, or if like not aware of what exactly the concept, you just watch my previous session. So now here, so in this session we will be discussing about ionization energy. So here just see, second question from this classification of element is related to define IE1, IE2 and why ionization energy IE2 is greater than IE1 for a given atom, and discuss the factors that affects on the ionization enthalpy of an element. So this is the next question from periodic table to be focused. Okay, so it is very simple guys, definitely. See, this is from many days, from past 10 years you can see questions from periodic table are only 2. Okay, or in very few cases there will be a third question. Okay, the first question is periodic properties and how they are varies in group and periods, that is first question we discussed, and second question is this define IE1, IE2, first ionization energy, second ionization energy, and why second ionization energy is greater than first ionization energy and factors affecting on it. Okay, so this is the second question, and third one is like you just describe the blocks like SPDF blocks and their electronic configuration, that will be the third question from this periodic table. So only these 3 questions you need to focus most preferably from this second chapter. Okay, classification of elements. So let me cover this first of all, what exactly ionization energy means. See, it is very simple. See guys, here since I am showing this PDF, do not think that I will read whatever the line mentioned here. No, I will give you complete concept that is required to understand. Then after that I will going to give you one by one, like line by line explanation, so that everything will be feeded in your mind and you can directly attempt this in your final exam. Okay, so I suggest you to make a best answer from this, and also if you have any books you can add, if you want to add any other points to this, then it will be really well and good. If not, you can also take this as a final answer. Okay, so now just look at here what I am doing. what do we mean by ionization energy? See ikkada emantunnaru chudandi. So the minimum energy required to remove an electron from an isolated gaseous atom is called its first ionization energy. Okay, so what I am saying, the minimum amount of energy, see for example, if this is an atom, see this is an atom having nucleus at the center, so around we know there will be orbitals in orbits in which electrons will be revolving right now. So like this we will be having shells. Okay, so in this only we know electrons will be revolving around this nucleus. Okay, so now the minimum amount of energy required to remove the valency electron, valency electron from an isolated gaseous atom. For example, A is an atom, so it has some electrons in it, like this some electrons are there. So definitely if I want to ionize this, if I want to convert A into A plus, so what is the process happening here? So atom A is converting into its positive charge, it means one electron is removed right now. So now the minimum amount of energy, to remove this valency electron, to remove this one electron from its valency shell of an isolated gaseous atom. See, atom should be in gaseous state and it should be isolated form. Okay, the amount of energy required to remove an electron from neutral gaseous isolated atom is called its ionization energy. Now how many electrons we removed? One electron, no? So now you can call it as first ionization energy, that is IE1. What you can say? IE1. So first ionization energy you can say. Okay, so this is about first ionization energy. Now see, removal of electron from neutral state is relatively easy. Okay, see here we know nucleus is there inside which is positive charge and electrons are negatively charged. So both of them are opposite charge, that's why they will be more closely or more effectively attracted towards the nucleus side also, or they strongly bind to the nucleus. Okay, if this attraction between nucleus and electron is less, we can easily remove out the electron right now. You can easily remove out the electron. So now what happens to this ionization energy when we move down the group? See, down the group atomic radius increases, it means the size of elements increases. What I am saying, size of elements increases. When this size increases, so when this size increases, nucleus is at here, and as we go down the group elements, so their size increases, so the electrons which is away from, which is far from the nucleus can be easily removed now. So down the group as size increases, ionization energy decreases. Okay, that's it, because effective nuclear charge on that last electron will be less because of large size, therefore we can easily remove out that final electron. So down the group what happens to ionization energy? Decreases. Remember this point. Okay, so now one more thing here you need to remember is, if I remove one electron, see from atom I am removing one electron, you should call it as first ionization energy. What we should call? First ionization energy. Now from this unipositive cation, what I am saying, this is cation, positive charge is there means cation you should say. So from this I am removing one more electron. What we are doing? We are removing one more electron. This is also in gaseous state. Now if I remove electron from here, it becomes A plus 2 and one more electron is coming out. This electron is I am writing here. Okay, so if I remove this one more electron, it will be becoming dication, dipositive cation, like dipositive ion. Okay, so this process is called IE2. What I am saying? IE2, second ionization energy. Now what is IE1 means? The amount of energy required to remove electron from a neutral gaseous isolated atom is called first ionization energy. And what do we mean by second ionization energy? The amount of energy required to remove an electron from unipositive ion is called its second ionization energy. Okay, so both definitions are clear now. If both definitions are clear, just click on the like button. Again I am going to explain this, no worries if not clear. Okay, so just see here, what I am saying here is, if you remove it from atom, one electron, that will be first ionization energy. If you are removing an electron from this unipositive cation, so that should be called as second ionization energy, that's it. And all these things should be in gaseous state only. Okay, this discussion should be remembered. Okay, so again I am repeating same thing in Telugu, just listen here. See, atom lo nundi oka electron తీసేసాం అనుకోండి, సో దిస్ యాటమ్ మస్ట్ బి గ్యాసియస్ స్టేట్. ఆ యాటంలో నుంచి ఒక ఎలక్ట్రాన్ తీసేసాం అనుకోండి, దాన్ని ఫస్ట్ అయనైజేషన్ ఎనర్జీ అని అంటాం. ఓకే, సో ఈ ఫస్ట్ అయనైజేషన్ ఎనర్జీ తర్వాత మనకి ఏమొచ్చింది, ఫస్ట్ యూనిపాజిటివ్ అంటే ఒక పాజిటివ్ ఛార్జ్ ఉంది కదా, సో 1 పాజిటివ్ ఛార్జ్ ఇస్ దే ప్లస్ 1 ఛార్జ్ ఇస్ దే. సో ఇందులో నుంచి ఇంకొక ఎలక్ట్రాన్ తీసామనుకోండి, దాన్ని సెకండ్ అయనైజేషన్ ఎనర్జీ అని పిలుస్తాం. ఓకే, సో ఫస్ట్ ionization energy, second ionization energy. So this is about first and second ionization energy. Now we need to compare first and second ionization energy. So how can we compare these? So always remember, so IE2 will be greater than IE1. What I am saying, IU2 will be greater than IE1. So why IE2 is greater than IE1? See, second ionization energy always greater than first ionization energy. Why? Because see for example, I have electron here, one electron, and second electron is at here. See, if this electron is far from the nucleus, there will be less attractive force between electron and this nucleus because they are far from each other, no? So we can easily remove out. Okay, so in the first case when I am saying atom, so it is neutral. If there is 10 protons in the nucleus, then there will be 10 electrons in the valence shells, I mean in these shells. In total electrons will be 10. Okay, so now but if I say unipositive cation, here if I say number of protons will be same, it means positive charges are same, but negative charges, electrons are how many? Already we removed one electron here, so it will be 9 electrons only. So now number of electrons is decreasing now, it means positive charge is more, negative charge is lesser. Now what happens if negative charge is less now, so the positive charged ions, now nuclear charge is more now, so that nuclear charge will strongly attract all the electrons. Now it is very closely attracting, the second electron is very closely attracting towards the nucleus. So removal of that second electron will be very difficult now because it is strongly held to the nucleus now due to more positive charge than the negative charge. That's why always the second ionization energy is greater than its first ionization energy. Remember this point. Okay, so now see why IE2 is greater than IE1. See, after removing one electron, so after removing first ionization energy, I mean first one electron, the atom becomes a positively charged ion. What it becomes? A positively charged ion. Okay, so it becomes a positively charged ion. So now from this the nuclear charge remains the same. Yes, 10 protons, 10 protons, nuclear charge remains same, but electrons are very less, fewer, but electrons are fewer. So the effective nuclear charge increases. What increases here? Effective nuclear charge is increasing. Thus the remaining electrons are held more tightly, so that more energy is needed. What I am saying, thus the remaining electrons are held more tightly. Yes, the remaining electrons are held more tightly, therefore more amount of energy is required to remove those electrons. So always remember, if we compare successive ionization energy, it means what? Like IE1, if I am comparing IE1, IE2, IE3, like this if I take, so which is greater? So the one which is at the last, I mean IE3 will be greater than IE2, like that we can say. Okay, so as positive charge on that atom, that ion increases, electrons are more closely packed or more closely attracted towards the nucleus, so it is very difficult to remove that valence electrons. Okay, so that's why always remember the successive ionization energy always increases, like IE3 is greater than IE2 is greater than IE1. It means, let us take one example here. See, here I am taking boron. Okay, what is the electronic configuration of boron? So you can write 1s2, 2s2, 2p1, 2p1. So its atomic number is 5. This is the electronic configuration. So if I want to make it unipositive, so it will become B plus. So B plus means from where we are removing electron, from here now. So it will be now what is the electronic configuration? 2s2, 1s2, 2s2, and 2p0 it becomes. Okay, so now how many electrons are there? See, 4 electrons only there, but protons are 5. So here protons, nuclear charge is more, but electrons are less. So these electrons are very closely packed now, very closely attracted towards this boron nucleus. So it means it is very difficult to remove this this second electron from here. Okay, this electron from here. So it means this is called IE1. This is called IE1, and from, if I remove from here, it becomes IE2, that is second ionization energy. I am writing IE2, therefore it becomes B plus 2. And what happens to electronic configuration? It will be 2s2, 1s2, 2s1, and 2p0, like this now. So this is second ionization energy. Now what about third ionization energy? It becomes B plus 3, that is IE3. This is 1s2, 2s0, like this we can write right now. So hope the concept is also clear. So now when I compare IE1, IE2, IE3, which is greater? Always this last one, IE3 is greater than IE2, then IE1. Remember this concept, okay? Right, right. So is the discussion is clear or not? Yes, tell me in the chat box, is this discussion is clear or not? Yes, if it is clear, just click on the like button. If it is clear, just click on the like button, everyone, those who are in the live session or watching recorded version later on. Right, right. Then next here, the things that we have given in these notes are completely cleared now. So now what you need to do? So just sit, take a white pen paper, take one white sheet or notes and make your answer from this. Each line by line we have explanation also here right now. So right, the next here, so this is a scenario how ionization energy changes, across a period. So if you write these 2 points, that examiner definitely get impressed and he will give you full marks for this ionization energy. So variation of ionization energy, IE across a period, okay, across a period. How it will varies across a period? It means just take second period elements or third period elements, whatever you want. See, let us take second period elements I am taking. So what are the second period elements? Lithium, next beryllium, boron, carbon, nitrogen, oxygen, fluorine, like this you take. Up to halogens only I am considering, not inert gases. Okay, so now even if you consider inert gases also, no issues, because inert gases have stable electronic configuration, so it will be having maximum ionization energy. So greater ionization energy is always noble gases here. Just see here, noble gases is having highest. Okay, why? Because it has stable electronic configuration like 2s2, 2p6 we are writing. So that's why neon is always noble gas in that respective series will be having highest ionization energy, remember this. Okay, so after this fluorine, okay, after this fluorine here, okay, and after this between nitrogen and oxygen, both of them are electronegative. Along with this electronegativity, write their electronic configuration. So here it is 2s2, 2p3, here it is 2s2, 2p4 right now. So 2p4 here, removal of electron is easier, and here it is difficult because it is half filled electronic configuration. So nitrogen is half filled electronic configuration, so removal of electron is difficult. So do not remove from here, it means it is very difficult. So nitrogen will be having greater ionization energy when I compare with oxygen. So it requires more energy, that's why I am saying nitrogen is greater than oxygen. After this carbon, we have boron and beryllium. Boron is having 2p1 electronic configuration at the end after this 2s2, but this is having only 2s2. So removal of electron from s orbital is difficult when compared with the p1. Okay, so that's why beryllium is greater than boron, and least is for lithium. So this is the order. If you write this order in the exam, definitely you are going to get good marks along with the explanation. Okay, and after this down the group, what I told you, down the group, as we move down the group, just take some elements. See, this is variation of ionization energy down the group. So how it will be? It is decreasing. See, it is decreasing. So if you want to take a group elements like alkali metals, we can take. So lithium, sodium, potassium, rubidium, cesium you can take. So which is having greater ionization energy, they will ask. So down the group size increases now. So as size increases, that valence electron is very far from the nucleus when we compare with this right now. So if it is very far from the nucleus, easy to remove the electron now. So less amount of energy is required. So less ionization energy is for cesium. Down the group ionization energy decreases. So this will be the scenario of ionization energy in groups, and this is in periods. Okay, so make a note of it, and which is very important. Okay, right. Now what are the factors affecting here? What are the factors affecting ionization energy? What are the factors affecting ionization energy? Okay, so look at this discussion of factors affecting ionization energy we are discussing. Yes, tell me, what are the factors are affecting here? See here, first of all, atomic radius. Just now I discussed about this atomic radius. What happens to size down the group in periodic table? Size decreases now, so size increases now down the group. When size increases, it is easier to remove the electron. So ionization energy decreases. As size increases, ionization energy decreases. So it means larger the size, weaker the nuclear attractions, so easier the removal of electron, that is lower ionization energy. So ionization energy is inversely proportional to atomic size, we can write. So IE is inversely proportional to atomic size. This is perfectly correct. Okay, so this is about atomic radius. Then next here we have nuclear charge. So what about nuclear charge? Nuclear charge is nothing but positive charge. As positive charge, effective nuclear charge increases, now this effective nuclear charge, positive charge attract the electrons more effectively now. So more nuclear charge more effectively it attracts the electrons, so it is very difficult to remove the electron. So ionization energy also more, higher ionization energy is required. So greater the nuclear charge, stronger the attractions, so higher is the ionization energy. So simply you can remember ionization energy is directly proportional to nuclear charge. What I am saying, ionization energy is directly proportional to nuclear charge. Okay, and the next, the third factor here is the screening effect or shielding effect. What do we mean by screening effect or shielding effect? See, for example, we know down the group as atomic number increases, so down the group atomic number increases, so atomic number increasing means number of protons are also increasing, as well as electrons in the valence shell also increasing right now. So it means if you want to write this one, just write here like this. We are representing orbitals right now, like shells we are representing, orbits we are representing right now. Okay, like this we are representing. Now what happens is, removal of electrons from this valency shell is called ionization energy, first ionization energy. So if we remove this electron easily, it will be having lower ionization energy, we are saying right now. So now if this positive charge, this nuclear forces are very effective on this, if it is more effective on this, then electron will be strongly holded and it is very difficult to remove. But inside, if there is something between this nucleus and this electron which is stopping them, I mean this force is now decreasing on this, attraction force is decreasing on this electron, so we can easily remove this electron now. So that's it. So if there is anything like shielding between these nuclear forces on this electron, so electron can be easily removed. So what is this here? See, shielding effect or screening effect. If there is something like a screen between electron and a nucleus, so we can easily remove this electron out. So look at here, inner electron shield outer electron from the nucleus. So higher the screening, lower is the ionization energy. If this is more screening, here what do we meaning of screening here? See, if there is more number of electrons present inside like this, now what these electrons will do? They will shield this outer electron. It means they will decreases the effective nuclear charge on this outer electron, because more electrons are there inside now, so that will only stop the nuclear forces on that outermost electron. If they are acting like a screen here, so if there is no nuclear forces or less nuclear forces on outer electrons, it is easier to remove now. So that's why if shielding or screening effect is increasing, so we can easily remove electron, valence electron out. It means lower will be the ionization energy. So see, greater the shielding, lower the ionization energy. They are inversely proportional. Higher the screening, lower is the ionization energy. Okay, right. So this is also clear now. So if these factors are clear, just again click on the like button. Okay, right. Next thing here is, fourth factor here is penetrating orbitals, like penetrating capacity of orbitals we can say. So what do we mean by penetration of orbitals? See, if I consider this is a nucleus, Okay, around this nucleus we have orbitals like this. Okay, shells we have like this. In that shells we have subshells like S subshell, P subshell, D subshell, F subshell we are writing right now. Again in that subshell we have orbitals like S orbital, P orbitals, D orbitals, F orbitals. Okay, so now S orbital shape is a spherical, so it means around the nucleus there will be spherically symmetric right now. So it will be symmetric around the nucleus. When it comes to P orbital, it will be like a dumbbell shape. When it is a D orbital, it will be double dumbbell shape like this. So now as we are moving from S to F, they are having less symmetric. It means S orbital is more symmetric around the nucleus. So whatever the electrons present in the S orbital are strongly attracted towards the nucleus like this. If they are strongly attracted towards the nucleus, it means that electrons, that S electrons are strongly held to the nucleus. So it is very difficult to remove the electron from that S orbital. So always remember the penetrating capacity. It means the closeness of that orbital towards the nucleus will be more for S, after that P, then next D, and least is for F. So more closer to the nucleus, harder to remove the electron. So it is very hard to remove electron from S, then P, then D. So it means high ionization energy will be seen in case of S orbital electron when we compare with P. Okay. So for this, the best example here we can consider is beryllium. I am taking beryllium and boron. So which is having more ionization energy, they will say. So what is the electronic configuration of beryllium? We are writing as 2s2, 2s2 for beryllium, 1s2, 2s2 for beryllium, and when it comes to boron, you are writing 2s2, 2p1 electronic configuration, valence electronic configuration. So here it is same shell number now. So compare the subshells now. This is S, this is P. So from where we can easily remove, since this S orbital is more close to the nucleus, so it is difficult to remove electron from S. Therefore we are removing electron from this P easily. Therefore boron require lower ionization energy when we compare with the beryllium. So this will be the order of this ionization energy. It is purely based on this penetrating capacity of orbitals. We are giving that order. Okay. Hope this discussion is also clear. See, the same concept you can use for your JEE, NEET and EAPCET preparation also. So what I am giving here, so along with this IPE discussion, this like whatever the notes you required for your IPE, I am presenting here. I am explaining each and every line with a proper explanation right now. Yes, if the things are clear, just click on the like button guys again. Right. You can also share your feedback in the chat box. If you have any concerns or you want me to cover any particular topic, you just mention in the chat box. In the live chat, I will be able to discuss with you. Yes, anyone in the live chat, you can write your queries. And if you are anyone is from Hyderabad, yes, you can come to our institute also. It is in our NEET, like it is in our Narayanguda, Hyderabad. You can come here and you can join in these offline sessions also for this your IPE and EAPCET preparation. Okay, right. You can have these demo sessions also with us. Okay, so yeah. So look at this. Next one is stable electronic configuration. It means whenever there is stable electronic configuration, removal of electron from that stable electronic configuration is difficult. Why it is difficult? Because it is already stable electronic configuration. So if I remove one electron, it becomes unstable electronic configuration now. That's why whenever there is stable electronic configuration, it is highly difficult to remove electron. Okay. So due to this reason, between nitrogen and oxygen, if I compare, since oxygen is more electronegative, it should be having more ionization energy, we consider like that. But due to its electronic configuration factor, this is having 2s2, 2p3 electronic configuration here. This is 2s2, 2p4 electronic configuration here. So here p orbitals are 3 now. So it is having half filled electronic configuration. For which one? Nitrogen. That's why half filled is stable. So whenever they have half filled or completely filled, it is very difficult to remove the electron from them because they are stable electronic configurations. Okay. So that's why it is required high amount of energy, that is ionization energy of nitrogen is greater than oxygen. So this will be the scenario. Okay, so nitrogen is greater than oxygen. So because of its stable half filled electronic configuration of nitrogen, that's it. Okay, remember. Okay, next term. So IE, ionization energy of nitrogen is greater than oxygen. You need to write this explanation also. Okay, then next. So this is about the factors. There are 5 factors I have explained, and what is the definition of ionization energy, comparison of first ionization energy, second ionization energy, and factors affecting ionization energy. These are the 3 factors to be known for you during your exam writing, answer writing for this particular question. And the next question from this chapter, this is the like less expected questions, but anyways we will make a clear cut idea on this question, because if it comes we should ready to answer them in the exam. So write an essay on SPD and F block elements. So write an essay on SPD and F block elements. So we know in periodic table, if we consider, so it will be looks like this, something like this. Here you have P block elements, here you have S block elements, and in between them we have D block elements. This is S, this is P, this is D, and here in this D only, so here you have lanthanides, like 14 elements are there here, and actinides, here one more 14 elements are there here. Okay, so these are what, these 2 are what now, these are F block elements. What I am saying, these are F block elements. So this is the rough imagination you should have when you are discussing about periodic table. Okay, so now how do we classify this periodic like elements into different blocks here, S block, P block, D block, F block we are saying now. So how do we classify them? So based on the last electron that is entering into which orbital, so based on that we have classified. See, based on the entry of last electron, that is what we can say differentiating electrons into the atomic orbital. Elements are classified into 4 blocks, classified or divided into 4 blocks in the periodic table. So what are those blocks? S, P, D and F blocks. Okay, these are the 4 blocks we have classified. Now what exactly S block elements, how can we say them as S block elements? See here, if the differentiating electron, if the differentiating that last electron, if it is entering into the outermost S orbital, then we can say it as a S block element. Okay, so now give one example. Sodium atomic number is 11, so you can write a 1s2, 2s2, 2p6, so 10 electrons over up to here. The next 3s1, so last electron of this sodium is entering into the S block orbital, S orbital right now. So last electron of this 11th electron of this sodium is entering into the S orbital right now. So we can say this sodium belongs to belongs to S block element, S block element. So now how many S electrons are there? 1 now. So it is 1s block. It means there are 2 groups in this S block. So how many groups are it has? S block has 2 groups. It means this is 2 group. This is 1a group, this is 2a group. Okay, now it is having 1 electron in this S orbital, so it becomes to it belongs to first block, first group, that is 1s group. Okay, so now if you take magnesium, Mg magnesium, you take 12 atomic number. So what you are writing up to here 10 electrons as it is, 1s2, 2s2, 2p6. Okay, up to here 10 electrons are over. Just count 6 plus 2 plus 2, 10. Okay, after that you have again 10 electrons over, means 3s2. All 12 electrons are written. So the last 2 electrons are entering into the S orbital now. So it means how many electrons are there in this S orbital? 2. So it means it is belongs to 2a group. Okay, which one? 2a group. Okay, so group 1a alkali metals, those are NS1. Okay, it is having like this can be now considered as N. So N and S1. So what is the general electronic configuration of first A group elements in the periodic table? That is NS1. Okay, and similarly what is the general electronic configuration of 2A group elements? That is NS2 electronic configuration. Okay, so for 1A group we can call them as alkali metals, and 2A groups are called as alkaline earth metals. What I am saying? Alkaline earth metals. This is alkali metals, alkaline earth metals, that's it. Okay, so for complete S block elements you should make a general electronic configuration as NS122. If it is 1, first group elements, if it is 2, second group elements, that's it. This is what first block, that is S block elements. Okay, right. This is clear now? Yes. So now what is the position of this S block elements? These are left side of the periodic table. See, this is left, middle and right. P block elements are right, S block elements are left side. Okay, and the next properties. So what are the properties of S block elements? So S block elements are highly electropositive. So they are highly electropositive. It means whenever they combine with some other elements, like from lithium to cesium, if you consider, so whenever they combine with any other elements, any other species in the nature, they will always stays with a +1 charge on them. So oxidation state will be +1 like this. So their properties are highly electropositive and they are highly reactive also. If you place this like first A group elements in water, you are going to see exothermic reaction, you are going to see a fire. If you throw sodium metal in the water, you are going to get a explosive reaction, like fire will be released from there. Okay, exothermic reaction. Okay, so that's why I am saying these are highly reactive and highly electropositive, and they stays in +1 oxidation state in their combined state, and these are good reducing agent. What do we mean by reducing agent? Now what I told you, they are highly electropositive. Now if means if I take lithium atom, so this is always tries to be in its positive nature, like +1 nature. It means 0 converting into +1 means 1 electron is coming out now. So this electron is taken by other species. Now the one which is taking this electron will undergo reduction. Okay, so will undergo reduction now. So by what? This fellow is releasing electron and that species is taking the electron. So I can say, since it is releasing the electron, so it has more tendency to release an electron, means more ability to releasing the electron, means more reducing nature it has. So they have a strong reducing nature character. So they can be a reducing agent, good reducing agents also. Okay, so now which is strongest reducing agent? If someone asks, that will be lithium here. Okay, remember that. After that, we need to study about P block elements. So what are the P block elements we have? So we have in the like periodic table, the P block elements are from 13th group to 18th group. From where to where? 13th group to 18th group. So now how can we decide whether an element is P block or not? If that last electron of the element entering into the p orbital, then we can say it as P block element. For example, boron again you take, or carbon you can take. What is the atomic number here? Writing 5, here 6. So it will be 1s2, 2s2, 4 over, and fifth electron is 2p1 here, like this. And for this it will be again 1s2, 2s2, 2p2 here. Like this we are writing their electronic configurations right now. So where you are seeing the last electron here is coming into the p orbital. So that's why these elements are belongs to P block. Okay, right. Now look at this. If the differentiating electrons enters into outermost p orbital, then we can say these are P block. So how many groups we have? 6 groups, 6 P block, 6 groups are there in this P block. Okay, from where to where? From 13 to 18. It means 13, 14, 15, 16, 17, 18. Okay, now what is the general electronic configuration? See, 13th group, 14th group we are saying now. So for 13th group, the general electronic configuration, see, boron belongs to this 13th group only. So now how many electrons are there in the valency? So do not consider this, this is 1s, it means helium gas configuration. After this noble gas, we need 3 more electrons to get this boron right now. So it will be ns2, I can write ns2, and here np1 NP1 for this 13th group elements, NP1. Okay, for 14th group elements it is NP2, 15th NP3, 16th NP4, 17th NP5, 18th NP6. So it means varying from 1 to 6. So NS2, what is the general electronic configuration? You can simply write it as NS2 NP6. So that is what I am writing here, NS2 NP126, 126, depending upon the group number it can be 1, 2, 3, 4, 5, 6 in this NP orbitals. That's it. Okay, right. Next here look at this, the position of these p block elements will be right hand side of periodic table, right side of periodic table. Properties. So now this periodic table in this p block elements we can have, it includes metals, there are some metals and there are non-metals and metalloids also we have. Okay, so at the top we have non-metals and in the middle we will be seeing some metalloids, and at the bottom of the periodic table we will be seeing metals. Okay, so down the group metallic nature increases. This is what you need to remember for this p block elements or this periodic table. Okay, so now what are the examples here? See, group 13 or group 3A, this is belongs to p block. All these groups are belongs to p block. Okay, how many are there? 6. So group 13 elements are boron family, that is having electronic configuration as NS2 NP1, and next carbon family, that is 4th A group from NS2 NP2 electron. 14 now, see 4th now, it means 14th group you can say or 4th A group you can say. Okay, so there should be 4 electrons here. If you are saying 4th A group, 4 electrons. If you are saying 14th A group, that is nothing but 10 plus 4 you can write. How many electrons are extra on this 10? 4 now. So that 4 valence electrons should be written here. So if I say this is a 13th group, that is 10 plus 3, or simply you can say 3A now. So 2 plus 1, how much? 3, that's it. Like that you need to consider the electronic configuration for better understanding. Okay, right. Next, nitrogen family here, nitrogens we can say having NS2 NP3 electronic configuration. Next, oxygen family NS2 NP4, 16th group or 6th A group you can say. This is 17th group or 7th A group, halogens like this. Okay, and this is 0th group or 18th group you can say. So 18th group is having how many valency electrons? 8 valency electrons. 10 plus 8, that is 2 plus 6 here, 8. Okay, and there is one exception, that is for helium, it is only 1s2 because helium atomic number is 2 only. Okay, now after this we have neon, argon, krypton, xenon, radon, all of them are having NS2 NP6 type of electronic configuration. Okay, so everything that is related to p block element that must be shown in the exam if this question comes, were discussed here right now. So now d block elements to be discussed. So do you know anything about d block elements? Yes guys, anyone in the chat box? Let me take some water. Yes, tell me. Yes, tell me how can you decide these d block elements? Again, the differentiating, if the differentiating that newly added electron, if that enters into penultimate d orbital, what do we mean by penultimate d orbital? That is n-1 d orbital. It has d orbital, then we can say it has a d block element. For example, you can take here titanium, I am saying titanium, scandium, titanium, vanadium, chromium, manganese, all these are d block elements. Okay, so now if you want to write their electronic configuration, just see here. So scandium atomic number is 21. What I am saying, it is 21. Okay, so generally how we are writing electronic configuration, like 1s2, 2s2, 2p6. So how many electrons over? 10 over now. After this 3s2, 3p6. So how many over? 18 electrons are over. Okay. So now 21 means 3 more electron to be filled. Then next here we will get a 4s orbital. After that we will get a 3d orbital. So it means if you are filling, what is the last n value, highest n value is how much here you are seeing? Here you are seeing n value highest possibility is 4. Okay. So now 4s2 electrons are filled. It means from here to here if you count 20 electrons are over. Okay, 20 electrons are over. But what I am saying, the last electron is a differentiating electron that enters into the n-1d orbital. n-1d orbital means what? What is the n value here we have? N is equals to 4 we are saying. It is not entering into this. Last electron is not going into this fourth shell, but it is going into n-1. That is n-1 means 4 minus 1 d orbital. That is 3d orbital it is entering. Just check here. The last electron come here. So this is 20 plus 1. This 21st electron is going into the d orbital now. So that's why scandium belongs to d block element. Okay. So d block it belongs to. Similarly, titanium, vanadium, chromium, manganese, for all of them have that last electron were entering into this d orbital only. That's why we are calling them as d block elements. Okay. So now it has 10 groups in total. It means there are, see, there are 3D series, 4D series, 5D series and 6D series, 6D series. Okay. So now in each of this series there are 10 elements like this. So what I am saying, there are 10 elements like this which are belongs to each d block element. Okay. So now what I am saying here, there is 10 groups in it has 10 groups in total. It means like this, how many columns of d block elements will be there? There are 10 columns of this d block consist. Okay, d block consists 10 columns, that is 10 columns are nothing but each column is called as one group. So like that 10 groups are there. Okay, remember. Okay, I am saying now like this rows are there, this 3D row, 4D row, 5D row. So each row is called as a period. So this is 1, 2, 3, 4 periods are there here like that. So this 3D series is in 4th period. Why? Because 4th period, what is the highest n value here you are seeing? 4 now. So this is in 4th period. Similarly, this will be in 5th period. This is in 6th period. This is in 7th period. Like that you need to understand. Okay. So one number is greater for period when we compare with that series. Okay. Remember. Okay. So now here they are 3B to 7B. It means periodic table, if you observe, this is as per the normal classification. If you are going for IUPAC, it will be from 3 to 12. Okay. If you are talking in terms of normal numbering, that is Mendeleev classification, we can have 13th B to 7th B. And the next 8th. So 8th group contains 3 vertical columns. Okay, like this. After that we have 1B and 2B. Okay, just take any periodic table and you can observe this will be the scenario. Okay. Now what will be the general electronic configuration? It will be having what you are seeing here, n-1 you are seeing now, 3D means n-1 only now. So you can write n-1 d1 to 10, d1 to 10. The next ns orbital will be there 1 to 2. That's it. This is the general electronic configuration of d block elements. Okay. So now what is the position of these d block elements? It is in between, d block elements are in between s and p block now. Yes sir, position is in between s and p blocks in periodic table. Okay. The next, so now these d block elements are divided into 4 series. Each series contain 10 elements. That is what I have told, 3D, 4D, 5D, 6D. Okay. Now 3D series is from scandium, atomic number scandium 21 to zinc, that is 30th element. Okay. Scandium to zinc. Similarly, 4D series contains yttrium to cadmium. Yttrium atomic number is 39 and goes up to cadmium 48. And after this, 5D series contains lanthanum, which is atomic number 57. Lanthanum belongs to d block element only. Okay. But within that lanthanum series, in that group, we have in that series we have F block elements also included. So after this lanthanum 57, that 50th element to 71st element, these elements are belongs to F block elements. Okay, so these F block elements are placed at the bottom now. Yes, at the bottom after lanthanum, that's why we are writing directly hafnium, that is 72 atomic number. Again from 72 to 80, that is mercury. Up to that we have D block elements again. So lanthanum 57 comma hafnium 72 to mercury 80 or belongs to D block elements here. Okay, right. Again those are also 10 elements. Then next 6D series elements like actinide. Actinide atomic number is 989. After that we have actinides, and then after actinides again we have our D block elements. Okay, so in your NCERT book, if you consider, this is mentioned as incomplete, that's why it is also mentioned here incomplete, that's it. Okay, next. But as of now we have all the 118 elements in the periodic table. Okay, right. Next, properties. What are the properties of these D block elements? They are hard, heavy metals, and they have high melting and boiling point, and this is due to high number of more number of d orbital electrons, more number of unpaired electrons present in D block elements. That's why they have high melting points, and they also have greater atomic metallic bonding between the atoms that results to have more boiling point. Okay, these are the two reasons for their high melting point and boiling points, remember. Okay, so just write whatever the line we have mentioned here, that is more than enough in your exam. Okay, so now examples, this already we have written some examples for D block there. Again here some example, iron, copper, zinc are mentioned here for an example of D block elements. Then after this we have F block elements. Those are also called as inner transition elements. What do we mean by inner transition elements? See, here we have S block, and the next D block, and the next P block right now. So in this D block only, here we are seeing lanthanides, actinides right now. So these are in the transition elements now, so we can say inner transition elements. So now in inner transition elements, differentiating electrons enter into n-2 f orbital, where it goes n-2 f orbital. Now what is the general electronic configuration for F block elements? So it will be n-2 f 1214, n-2 f 1214, then next n-1 d 021 and ns2. It means what happens here is we are filling electrons in this f orbital after filling these ns electrons. Okay, so for example here what are the two series we have? So two series are lanthanides and actinides. So this is called 4f series, this is called 5f series. Okay, so now for example if I want to write for this any of this lanthanum, for lutetium if I am taking, so atomic number is 71 now, or any element you can take here. See, xenon is 54. What I am saying, xenon is 54. Okay, after this we need to write for these elements. Okay, here we have 4f, okay, next 5d, then next is 6s. So electrons first goes to the 6s orbital, like 2 electrons will be filled. After that we have one lanthanum element now, so it might be having 1 electron here, then that next electrons will come here from 1 to 14, like this it will varies. It can be have 1 electron, 2 electron, 3 electrons, depends on type of atom or which element that is from lanthanides. Okay, like this we can write. Sometimes this d electron also goes to f orbital only, so there are some variations. So you no need of writing all those electronic configurations during the exam. Just write its general electronic configuration as n-2 f 1 to 14. This is f 1 to 14, in the power you can write f 1 to 14. The next here n-1 d 0 to 1, and the next ns2. That is what the representation. Next, what is its position? At the bottom of the periodic table. So if this is periodic table, here we have 2 rows here at the bottom. So this is lanthanides, these are actinides, that's it. Okay, right. So during the exam also you just show a rough diagram of periodic table clearly, that S block elements have, S block has 2 groups, 1s, 2s, P block has 6 groups like this, 6 groups in P block, and the next 3D series, 4D series, 5D series, 6D series. Okay, like that you just show, and right here it is S block, this is P block, and this is D block, and here it is F block. So if you write like this, yes, whoever correcting your paper will get that, yes, this student might have a good understanding on the periodic table, so he is clear with the table, so whatever he are writing is almost correct only, so he will get a good impression on your presentation right now. So these are some new like simple tactics to be played to get maximum score during the exam. Okay, right. Next, so what are the properties of these elements? So here thorium, uranium are naturally occurring elements, and remaining are man-made elements. So what they are saying, these are synthetic, it means they prepared in the laboratory. Okay, so they prepared in the laboratory. So mostly metals, so all these are metals, so many of them are radioactive. What we are saying, many of them are radioactive, and some example you can remember like cerium, uranium, thorium, protactinium, praseodymium, neodymium, all this belongs to this F block elements. So whatever the names you remember during the exam, just write them on in the exam, during the exam, that's it. Okay, this is about the third LAQ of your periodic classification. So till now we have completed, three questions. Till now we have completed 3 questions from your periodic table. First question is periodic properties, second question is next ionization energies and their comparison, IE1, IE2, and third question is blocks like SPDF, describing the blocks, SPDF blocks of this periodic table. So these are the 3 questions we completed, and in the next session we will be covering chemical bonding. Okay, so chemical bonding and organic chemistry we need to study now. So these are the 2 chapters we can expect. I mean, 1 question from any of these 2 chapters we can expect in LAQs, and remaining chapter will come in the SAQs. Okay, so do not worry, we are here to cover all these things. So just stay connected with us, and you can make your preparation effective for your upcoming IPE examination. Okay guys, do not forget to click on the like button if you really like the content, and also you can share with your school friends, college friends, those who are for studying class 11th and class 12 and seriously preparing for their IPE and EAPCET exams. Okay, so thank you for watching, stay connected with us, thank you.